Over 15 years of a tradition of excellence, a leader in molecular spectroscopy. B&W Tech, providing solutions for Raman Spectroscopy for over 15 years. B&W Tech's Raman solutions help you maintain the highest levels of integrity, quality, and safety. That's why companies all over the world turn to us for solutions in an ever-growing global supply chain business environment. We have been behind the scenes for over 15 years, giving you superior results and first-class user experiences. B&W Tech has a full, innovative lineup of portable and handheld devices that refine and simplify the material acceptance process. Easy to use and allowing for greater flexibility. B&W Tech instruments help you more efficiently manage resources and materials suppliers. B&W Tech has the enabling technology to help transition toward 100% material inspections within highly regulated industries such as pharmaceutical and nutraceutical manufacturing. Plus, our devices have an unbeatable return on investment. Not only do they increase productivity and integrate seamlessly into your current workflow, B&W Tech instruments reduce material hold and labor costs in material acceptance processes. We pride ourselves on the excellence and ease of use of our NanoRam products. Our intuitive software is specially designed to be user-friendly for both technical and non-technical users, and complies with 21 CFR Part 11 regulations. The NanoRam is also extremely versatile. Now, measuring a variety of samples in a variety of packaging can be done all from the same unit, simplifying the process to make your job easier. With the highest levels of performance and data reproducibility, B&W Tech gives you the confidence of knowing that results between units are consistent and reliable. But superior technology and instruments aren't the only reasons why B&W Tech is an industry leader. Our personal relationship with each and every one of our customers ensures a smooth implementation customized for your facility. B&W Tech's exclusive pre-to-post support and service never ends. US, Europe, China, Japan. We have over 200 full-time employees in offices around the world. But no matter where you are, you have our full suite of client-focused support services ready for you when you need us. So why choose B&W Tech? We have the most experience in the field of mobile molecular spectroscopy. We have created more innovative, cutting-edge instruments than anyone else, ever. We have over 200 full-time employees ready and waiting in facilities around the world to ensure your success. We currently have over 10,000 Raman spectroscopy systems being used in the field in diverse applications like raw material identification, university research, biomedical diagnostics, art and archaeological conservation, and more. We are a leader in the industry. We are B&W Tech. See the difference 15 years of excellence makes. B&W Tech, your spectroscopy partner.
There are several interchangeable accessories that can be joined with the macro RAM to make the instrument even more versatile and flexible. Cuvette and micro cuvette holder and adapters. The solid sample holder for solids and powders. The thermostatable cuvette holder for temperature measurements and flow cell are seamlessly integrated into the system. And an assortment of Raman probes are compatible for spectrum acquisitions from any sample.
This demonstration is going to be related to the pharmaceutical industry and is going to focus on quality control of incoming materials. I have 3 different materials and 3 different ways to use the macroram and accessories to measure these samples. The first material here is ethyl cellulose, which is a powder. So I've put the powder into the sample block and covered it with a quartz cover slip, and then placed the block into the solid sample holder. I'll take the sample in the holder and place it into the macroram, close the lid, and acquire data for the ethyl cellulose. Here's the spectrum for ethyl cellulose. The next material is oleic acid, which is a liquid, so I'm using the small volume cuvette. If you happen to only have a small volume of material, you can put it in a micro cuvette, place it into this little black adapter, and then into the cuvette sample holder. I'll open the lid, remove the previous powder sample and solid sample holder, and replace it with the cuvette holder with the micro cuvette inside. Close the lid and acquire the spectrum for oleic acid. You can see how easy it is to switch from powders to liquids, and if you have small volumes, you can also measure those with the macroram, as I've done here. Now you can see the 2 spectra together. The top blue one is ethyl cellulose, and the bottom green one is oleic acid, which is what's currently inside the chamber. I'm going to open the lid and pull out the cuvette sample holder, and as a side note, you can replace the micro cuvette with any standard size cuvette or with the HPLC flow cell. I'll make sure there's nothing inside the chamber and close the lid. And now I'm going to show you the Markmetrics half-inch ball probe. This is a touch or immersion probe, and it easily connects to the macroram via these 2 ports right here, a laser out port and a signal in port. After that connection is made, I'll turn the key switch from disable to enable the shutter, and then open the shutter in the software to allow the laser light to come out of the chamber and through the probe. Then you can use the ball probe directly as an immersion probe. Note that the laser is not turned on until measurement, and laser safety glasses should be worn when using the ball probe. I'll take the ball probe and immerse it into this large container of a medium chain triglyceride sample and press to acquire data. This is very simple and easy to use. It's good for high viscosity samples where you might have trouble getting the sample into a cuvette, and it easily wipes clean between each use. The red spectrum is the spectrum of the medium chain triglyceride, and all 3 spectra are shown for comparison. Altogether, I've shown 3 different ways to measure 3 different incoming raw materials commonly used in the pharma industry. This is definitely useful for QC purposes. I'm going to show one more way to measure the medium chain triglyceride sample. This time, I'm going to use the superhead instead of the immersion probe. The superhead is a non-contact probe, and it connects just like the ball probes via 2 ports, laser out and signal in. I'll switch the key from disable to enable, open the shutter in the software, and then I've placed my sample, which is in a plastic container, at some distance in front of the superhead, and I'll click to acquire a spectrum. You can instantly see the spectrum for the medium chain triglyceride measured without any contact via the superhead. I showed the same spectrum for the immersion probe, so either technique is viable here. And you can use the superhead to measure through glass bottles, cuvettes, plastic, or other containers for a quick and easy measurement.
The sample is the aspirin in powder on a microscope slide. The microscope slide is placed on the motorized stage. First step is to visualize the surface of the sample. So I will start LabSpec6 software and I will select the video mode. For the sample visualization, I will choose 10x objective. Using the joystick and the stage wheel, I will focus on the sample, checking in the same time on the computer screen. As you can see, there are several crystals with different sizes and shapes, and I will select one of them. For the measurement, we will use a long working distance objective, for example 50x objective. Then we will adjust the focus on the sample again. Let's choose the acquisition parameters. First, the excitation wavelength in this case will be 532 nanometers, and the grating will be 600 grating per millimeters. Because the sample is not photo or thermosensitive to the laser, 100% of the entire power of the sample will be used. An acquisition in real time will be launched for 0.5 seconds. This is the Raman spectrum of the aspirin obtained in 0.5 seconds. The Raman bands are narrow and very well resolved. Nevertheless, we note a small fluorescence background. It can be successfully removed by using an option called flat correction. So I will activate this option and I will launch again a real-time detection to see the changes. It can be easily observed that the background is almost eliminated. Now we have a very nice baseline. I will stop now the real-time detection and I will launch a Raman spectrum acquisition for 1 second. 2 accumulations will be used for a better signal-to-noise ratio. This is the Raman spectrum of the aspirin easily obtained in one shot, with a good signal-to-noise ratio, as you can see. For the further spectral analysis, we can follow, for example, the bands maximas. But follow us in the next how-to on the spectral analysis, coming soon.